Welcome to EDU World Space.
All right, Chapter 4, Problem 14. We have a velocity versus time graph of a 2.5 kilogram cat. 2.75 kilogram cat. And they want to know, maximum force on the cat. When is the cat's net force equal to 0? And what is the force at 8.5 seconds? So first we have to understand, what can I get from a velocity versus time graph? Remember that the slope of velocity versus time graph gives you the acceleration. So slope equals A. The area underneath the velocity versus time graph will give you the displacement, but they're not asking about that this time. So for A here, let's see, we want the maximum net force, F net at a max. That's going to occur where the acceleration is at a max. So when is the acceleration at a max? That's where the slope is the steepest. Where's the slope the steepest? Right there. So the slope gives us the acceleration. We have a rise of 8. We have a run of 2. The slope is 8 over 2. That's going to give us 4 meters per second squared. That's the maximum acceleration. So going over here, we're going to have the maximum force is going to be 2.75. That's the mass times that acceleration I just found. 2.75 times 4. And we end up here with a net force equal to 11 newtons. There's the max. Part B is asking, is the net force ever 0? We have to ask, is the acceleration ever 0? Is the slope ever 0? Yep, the slope is 0 from 2 all the way to 6 seconds. So that's our answer. From 2 to 6 seconds, we got no acceleration, no net force. And part C is asking, what is the net force at 8.5 seconds? So 8.5 seconds, we're somewhere right about there. We need the slope of that line. Okay, well, we start here. The rise is up 4, and with the run is over 4. So going up 4 and over 4. Wow, that was a nice 4. And so we got a slope of 1, which means the acceleration is 1 meter per second squared there. If F equals ma, then that's equal to the mass of the cat, 2.75 times the acceleration, which is 2.75 newtons. Super duper important that you remember that the slope of a velocity versus time graph is the acceleration.